Good afternoon. I'm Mr. Shantz. This is one of many, many videos I'll be making on the topics we do this year in Algebra 1. Sorry, let me mute that. So the first topic is the real number system. Uh, think of any number. Think of any number in the world. Okay? And no, it's pretty simple and it sounds dumb, but that number is a real number. Real numbers are noted are denoted as the letter R. And like I said right there, any number is a real number. Any and every number is a real number. And that's it for that. From the very broad category of real numbers, we can break it into two things: irrational numbers and rational numbers. I'm going to start with rational numbers because I think that those are easier to comprehend. But rational numbers are labeled with the letter Q. R was already taken, so Q is the next letter that I guess they wanted. Rational numbers come in many different forms. They can come in the form of like a fraction. They can come in the form of like a negative number without a fraction. Or they can come in the form of let's say a number with like a decimal that repeats. Let me get a pencil so I can put the little symbol for repeats. All right. I understand it's not red, but you get the gist, right? Rational numbers are pretty much almost every number is a rational number. I can give examples of irrational numbers in a second, but pretty much if it doesn't have a square root sign, after you simplify it, it's a rational number. Let's get back to the text box. From there, we move on, and we can even specify rational numbers even more. Integers are denoted by the letter Z. And integers are numbers without fractions or decimals. So these can be numbers like negative 12, 3, 1,000. These numbers are examples of integers because they do not have any fractions or decimals. They have no partial value, like half, third, 3/4. Okay? So those are integers. And then we can even specify integers even more. And we have whole numbers. Whole numbers are just like integers, except they can only be positive. They can only be 0 and up, really. Not positive, but 0 and up. So the example would be 0, 1, 2. I guess 43, but we'll do 3, and then we'll just do ... because it goes on forever. So whole numbers are only different than integers. Again, whole numbers have no decimal or fraction, but they also can't be negative. And then we move on to the last one, natural numbers. Natural numbers, denoted by the letter N, are just like whole numbers. They're just like whole numbers, except they don't have the number 0. The only difference between natural numbers and whole numbers is the letter 0. Now, let's move back over to irrational numbers. These irrational numbers go by the letter I. I know that looks like a L, but that's a capital I. I can't change the font. Oh, yeah, I can't change the font. So that's an I. These come in the form of square root signs. Square roots, things that you can't simplify. So let me see if I can get I don't have the equation one, so let's see if I can kind of like jimmy my way into a square root sign. That's a square root. Yeah, I think so. So this would be like the square root of 3. Or I could do another square root sign. I know it's going to look a little sloppy, but... Or we can do like the negative square root of like 10. Or the last one, the last example we got. I also should put a comma right there because I wanted to note that they're separate. And the last example would be if you had a symbol pi. I don't know if you guys know, but pi is an irrational number. Pi looks like, let me get a drawing. Pi looks like that kind of, And if you guys can remember from years past, pi, I'm just going to write it as pi, equals like 3.1415926 dot, 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 dot. That's about as far as I can go as a math teacher, which is kind of lame, but we get the point. So pi kind of gives you it's a very quintessential, or it's a very basic example of a irrational number, because it has an unlimited decimal. The decimal goes on forever and ever, except it never repeats. So it has a decimal that goes on forever and ever, and it never repeats. So you have irrational numbers, and then you have rational numbers. And let's go down to let me zoom out, because I think that would help with when we do number 30. Number 30, we want to classify it one by one. So we first look up and we go in order. We go, is 30 a real number? Well, all numbers are real numbers. So we're going to do, boom, R for real. And then we go down the list. I like to do irrational first, because as we do this, we go down one path, and if it's not irrational, we go down the next path. And then we just keep going until it doesn't classify that as that anymore. So we'll do 30 first. So it wasn't irrational because it doesn't have an ugly square root, or it's not pi. Now let's go rational. Well, if it's not irrational, it's rational. And then you can kind of call 30 like that like negative 13 type of number, where it just has no decimal at all. So it counts as rational. And then we think, is it an integer? Well, again, like I said, integers are numbers without decimals or fractions. Does 30 have a decimal or fraction? Most people would say no. So we can say it's an integer. And then we just keep moving along. Is 30 a whole number? And then we think, what makes a whole number special? Well, whole numbers can't be negative. Is 30 negative? Nope. So we'll put W. And then the last one, we think, is 30 a natural number? Well, natural numbers just can't be 0 or negative. So is 30 0 or negative? Nope, we put N. And then we can keep doing that for every single number. And I like 11 because 11 is going to show us something special. So again, let's do negative 11. Is negative 11 a real number? Every number is a real number. Boom, R. And then we keep going. Is it an irrational number? Well, since it doesn't have a square root sign, we go, it can't be, no square root sign, it can't be irrational. So we go, it's rational. Boom. And now, is it an integer? Well, integers can be positive or negative. The only thing special about them is that it can't be a fraction or a decimal. No fraction or decimal, we can put Z for integer. And then we think, is it a whole number? Is negative 11 a whole number? Whole numbers can't be negative. So this can't be a whole number. So we stop there. And since we stop at whole numbers, we're not even going to try natural numbers. So we just go one by one by one, and we try to figure out what we know. All right? Let's do number 6. I know I'm skipping around, but I'm just trying to get a very vast majority of examples. Let's do number 6. So the first thing I think is I see a square root sign. I'm thinking, can I simplify that square root sign? So let's see, maybe. So what is the square root of 9? Well, if you guys remember, the square root of 9 is 3. So we can call this guy negative 3. So we just simplified it first. I think that's very important when we're doing these guys. We have to simplify first. Let's turn that back to black. Let's kick out. And let's go back to red. So is negative 3 a real number? Yes, all numbers are real. Is it irrational? Nope. Since it's got a radical sign or a square root sign, in other words, it's not irrational. So it's rational, so we'll say Q. Is it an integer? No fraction or decimal, so it's an integer. Z. And then is it a whole number? Whole numbers can't be negative. And since negative 3 is negative, we stop there. So that's a few examples of this. I think